Students, today we are going to look at PIC microcontrollers. My name is Dr. Pankaj Lande, and here in this series we are going to look at the PIC microcontroller, and to be very specific, we are going to look at the PIC 18F series in detail. In PIC microcontrollers, PIC stands for Programmable Interface Controller. Now these type of controllers are developed by microchip technologies. Now this company has a different kind of philosophy of designing a microcontrollers. So their first microcontroller was launched in 1976. After that they come out of with the series of different kind of microcontrollers. These were 8-bit microcontrollers, but their program instruction were 12-bit, 14-bit, 16-bit or even a 24 bits long. So every PIC microcontroller is designed with the Howard architecture, and some of the popular PIC families are called as PIC 10, PIC 12, PIC 16 and PIC 18. And the family that I was talking about, the PIC 18F family that we are going to talk about in detail, that was launched in the year 2000. Now if you compare this with the 8051, this PIC 18 is really a recent microcontroller, and it has a tons of facilities that we are going to look at. Now let us compare this series that those are available in the market. So the first series is a PIC 12 series, that is PIC 12XX, and XX represents a different kind of numbers. Now this number is depend upon how much amount of flash memory they have, how much amount of ROM they have, on chip ROM they have, and that number can be varied. But one characteristic is very common in them is that well, they are 8-bit microcontrollers and their instruction size is 12-bit wide, and that is why they are called as a 12X. Now the next microcontroller series is called as a PIC 16XX series. Now these are also an 8-bit microcontrollers, but their instruction is 14-bit wide. The next popular family that is called as a PIC 18. Now this is also an 8-bit microcontroller, but the instruction size is 16-bit wide. The next family is PIC 24XX, and in this family has a processing capability of 16-bit, but their instruction is 24-bit wide. And next to that microcontroller, which is a very high performance microcontroller, it's called as a PIC 32. Now here the computing capacity is 32-bit, as well as the instruction size is also 32-bit wide. Now here you can clearly understand that what is meant by different designing philosophy is. Normally what we have is, when we design a microcontroller, they are either of 8-bit, 16-bit, then we have a 32-bit, and it's called as a didactic scale. Whereas in a PIC microcontrollers, they have a different kind of philosophy. So even though the microcontrollers like PIC 12, PIC 16, PIC 18, all these are 8-bit microcontrollers, they do have a different size of instructions. And same in the case of 24. Now here the device has a 16-bit capability, but its program code that is a 24-bit wide. So that is a different philosophy. In a case of 32-bit, it's the same. Well, the processing capability of 32-bit and even the instruction size is also 32-bit wide. So it is a bit different kind of technology that the microchip is using for designing their PIC microcontrollers. In the next coming slides, we will see why they are having different size of instruction set. Now here in this table, you can see the comparison between all different family members. As you know that PIC 12, PIC 16 and PIC 18, all these are having processing capability of 8 bits, whereas PIC 24 is having a processing capability of 16-bit, and PIC 32, in this I have taken an MX series which has a processing capability of 32-bit. Now depending upon different version, we are getting different kind of program memory on chip. So in the case of 12XX series, we are getting up to 3 KB of a program memory. In the case of 16 series, we are getting 3 KB of memory size. Now in the case of 18 series, we are getting 2 megabytes of memory on chip. Now in the case of 24XX, we are getting 12 MB of memory on chip, and in case of 32MX series, we are getting 2 MB of on chip ROM. Now let us compare the number of pins those are available, because these pins are required to interface the peripheral devices. Now, in the case of 12 series, from 6 to 14 pins are available, and from 16F series the device can have the pins from 8 to 64, In 18 series, we can have a pin count from, let us say, from 18 to 100, and for 24 it is from 28 to 121. Whereas in case of 32 series, it can be, the count can be vary from 48 to 144. Now, why this pin count and the memory sizes will vary? As I told you, it depends upon this XX letters. So whatever the 3 letters after this series, those are put on. Depending upon that, the memory size, the pin numbers will be varied. In the same way, we can have a data memory. Now, the data memory is nothing but the RAM. In the case of 12 series, it is 368. It is in a case of 16F series, it is 1.5 KB. In the case of 18 series, it is 4 KB. In the case of 24, it is 64 KB. And in the case of 32 MX series, it is 256 KB. Now, when it comes to an instruction length, here you can see that in the case of 12 series, the instruction is 12-bit wide, even though the computing capability is of 8-bit. In the case of 16XX series, you can see that even processing capability of 8-bit, we are having an instruction size of 14-bit. In the case of 18 series, even though the computation capability of 8-bit at a time, you can see that the instruction length is 16-bit wide. In the case of 24 series, the computing capability is 16-bit, whereas the instruction length is 24-bit. And in case of 32MX series, here you can see that even though it has a 32-bit instruction, 32-bit processing capability, its instruction is also a 32-bit. Now, the speed also varies with the series. Here you can see that the first series is having 5 Mbps, speed of 5 Mbps. Then we have next series that is having 8 MIPS. This is million instructions per second. 18 series having 16 million instructions per second, so it can execute up to 16 million instructions per second. 24XX series also execute 16 million instructions per millisecond, but in the case of 32MX series, it can execute 83 million instructions per second. Let's talk about the features available within the microcontroller. Now, as you can see that as the series number increases, the number of features also increases. So in a case of 12XX series or 16XX series, this is called the basic series. So in the basic series, what we have is we have a PWM, we have a timers, we have a ADC with the 4 channels, we have a 5-bit DAC, and we have a comparator. Whereas with 16XX series, what we get is a 10-bit PWM, capture compare facility with the PWM, and we have a 12-channel 10-bit ADC. Even it has a watchdog timers, and even it has a born out reset kind of a detector. What is that detector? That we'll see in detail later on. Now, the series that we are going to focus on, it is called as 18FF series. So in this series, we have a lot of facilities, like we have a SPI bus, we have a UART, we have a USART, we have I2C bus, we have a PWM. Now this PWM comes with a compare and capture facility. It has a ADCs, it has a 10-bit ADC with 8 channels, even it has a CAN bus, even it has something called as enhance, a capture and compare facility. So those are facilities, those are available within an 18. If you look at the next series, in the next series we do have all these facilities in the microcontroller, but at other it has some different kind of facilities. Like we in 24XX series, what we have is a 10-bit differential ADC is available with the 9 channels. Now, if you look at the very highest series, that is 32XX series, it has a PPM, it has a CAN, it has something called as a device nest, which is very popular nowadays. It has a 12-bit resolution of ADC, which sampling frequency is 1 million samples per second, and it has 48 channels, and it has on-board USB 2.0 connector, and it has Ethernet connector, and it has a DSP mode, and it has on-chip direct memory access. So as the number goes on, its facility goes on. Now when I say the more number of facilities are there, it means that we have a more number of configuration registers will be there. If you look at the number of instructions those are available, even though there are large number of facilities available within the microcontroller, in a case of 12xx series we have only 33 instructions. In a case of 16xx series we have only 49 instructions. Now in a case of 18xx series we have a total 83 instructions. In a case of 24xx series we have a 76 instruction, whereas in 32mx series we have a 93 instructions. So as you can see that if you compare with the 8051 microcontroller where we have a 256 instruction, here the number of instructions are really less. So these kind of computers are called as reduced instruction set computers. Here one more thing to see that this 12x series is called as a basic series, 16xx series is called as mid-range, and 18 onward series is called as a high performance range in the case of microcontroller chip families, where these series is optimized for C compilers. Now instead of writing an assembly language program, these are having a really large number of registers, and that is why these are optimized for embedded C programming. Let us look at reduced instruction set computer. Now let us compare the two terminologies those are available in a microcontroller or the microprocessor designing technology. The first technology is called as a RISC technology. In short, it stands for reduced instruction set computer. Whereas we have a different architecture or the different terminology to design any computer, it is called as a complex instruction set computer. Now this is the same for whether it is a microcontroller or whether it is a microprocessor. Now in a case of RISC architecture, we have a less number of instructions as set. Now as you can see that in a PIC 18F series or a PIC series that we have seen in the last slide, we have a limited number of instructions. So that is why this PIC microcontrollers comes under the RISC microcontrollers. Whereas in a CISC microcontrollers or the processor, we have a more number of instructions. Now, in a case of RISC, as we have a less number of instruction, we have a less number of addressing mode. Whereas in CISC, we have a large number of instruction set. So every possible addressing mode is there that is possible within the instruction set. Now, in a case of RISC microcontrollers, the instructions are very simple to understand. These are very simple instructions, whereas in CISC microcontrollers we have more complex instructions like div AB that we have seen in 8051. So this div AB can perform a division of A divided by B, or even we can access an external memory directly from the microcontroller, which is not possible in a RISC microcontrollers. So the complex task cannot be performed in a RISC microcontroller. To perform the complex task in a RISC microcontroller, we have to develop a separate program. You may think that if it doesn't perform any complex kind of task, then what is the use of RISC microcontroller, because we have to build a program? No, it's not like that actually. Whenever the number of instructions are less, it has a less decoding instruction set circuit. So whatever the microcoded ROM is there, it's very small. Whereas in a CISC microcontrollers, you require a large number of microcoded ROM, which will decode your instruction. Now here in a RISC, we have a less number of instructions, so the microcoded ROM is small. And in case of CISC microcontrollers, this microcoded ROM is very large. Now when I say it's small, it means that its manufacturing cost is small. When I say large, its manufacturing cost is large. So in a case of RISC microcontrollers, the manufacturing cost is reduces, whereas in CISC microcontrollers, the manufacturing cost increases due to a large number of instruction set, which requires a large number of decoding circuit, which is also called as microcoded ROM. So that we are talking about. Now the next part of comparison is that in a case of RISC microcontroller, what we have is uniform instruction set, whereas in a CISC microcontrollers, it is totally diverse. Now what is meant by that, I will tell you. In a case of RISC microcontroller, your instruction is either 2 byte wide or 4 byte wide. Okay, so not more than that. Whereas in CISC microcontrollers, we have a variety of instructions. So in variety of instructions, so the instruction can be a 1 byte, instruction can be a 2 byte, instruction can be a 3 byte, or even instruction can be a 4 byte in some microcontrollers. So that is the difference. Now, as I told you, this comes with a RISC, that is reduced instruction set microcontroller, so it has less cost. In CISC microcontrollers, we have all possible instructions, so that is why its implementation becomes very difficult and its cost is really very high. Now, whatever the controllers that we have seen right now, all PIC microcontrollers comes under RISC microcontroller series, that is reduced instruction set computers, and the controller like 8051 or Z50, or if we take an example of a processor which we have learned, that is 8085, is also an complex instruction set computer. So this was a brief comparison between RISC and the CISC terminologies. Those are used in a microcontroller or the microprocessor design. Now let us compare the microcontroller 8051, and I mean to say a core 8051 which was launched in 1980s, and that too compare with the PIC microcontroller, that is 18F series, and to be very particular we are going to look at the chip that is PIC 18F458. Now let us have a comparison in between these two. The first microcontroller was launched in 1980s. The second microcontroller, that is a PIC microcontroller, was launched in year 2000 or so. So both these microcontroller has a computation capability of 8-bit. Well, in a case of 8051, its maximum operating frequency is 12 MHz, whereas in PIC 18 series, the operating frequency can be of 14 MHz. So as the frequency increases, number of instructions executed within a second, that is also executed. So its unit is million instructions per second. Now, if you look at the IO lines, those are available in 8051, it is 32, whereas in PIC 18, we are having 33 lines. The number of interrupt sources, those are available in 8051s are 6, whereas the number of interrupt sources, those are available in PIC 18 series are 21. So the number is really large. Now, if you look at the timers, those are available in 8051s are 2, whereas in timers, those are available in PIC are 4. Now, in a case of 8051, we are having something called as USART. USART means Universal Synchronous Asynchronous Receiver and a Transmitter. Whereas, in a case of 18F series, we have a USART. But along with the USART, we have a different unit which is used for asynchronous kind of a communication. And it has a whole lot of serial communication buses. Those are available. Now here, the next point, you can see that the instruction set for 8051, if you look at its instruction size, the number of instructions that we are talking about is 256. Whereas in a case of PIC 18, we are having only 75 instructions. So that is why here we say it is a. Here is the difference that we are talking about. So in a case of CISC microcontrollers, we are having a large number of instruction set, whereas in a RISC microcontrollers, we have a less number of instruction set. Now here, as we have discussed earlier, in 8051 we are having 5 addressing modes, whereas in PIC 18 we are having only 4 addressing modes. As the instruction set number is less, we are having a less addressing mode. As the instruction set is large, we are having large number of addressing mode. And we have already discussed that this 8051 is a CISC type of a microcontroller, whereas PIC 18 is a RISC type of a microcontroller. Now here I want to point out one thing. Now in the case of PIC 18, we are having 75 instruction, whereas in the case of 8051, we are having 256 instruction. Now here in a PIC 18, we are having 75 instruction. It doesn't mean that it is a less powerful microcontroller that is available, and it doesn't make a more powerful 8051. It has a different kind of architecture that makes it possible to run on 75 instructions, whereas in the case of 8051, it has a different architecture which makes the possible to have all possible instruction set. Whereas if you compare PIC series with the 8051, the PIC microcontrollers are far more better or far more powerful than the core 8051 microcontrollers,